Hello there students, welcome to a continuation of our motion in one dimension series. This will probably be the last video we do on motion in one dimension. In this video, we'll be covering another practice problem with regards to motion in one dimension. Okay, so in this problem, we're given that our position function is 24t minus 2t cubed. So what this question asks us to do is that it asks us to find the magnitude of the acceleration when our velocity is equal to 0. So when velocity is equal to 0, we're asked to find the magnitude of acceleration when our velocity is equal to 0. And so by now, if you've been watching the other videos, you will know that velocity is the derivative of our position with respect to time. Velocity is the derivative of position with respect to time. To find the velocity, we'll first have to derive the position function. And so finding the derivative of 24t minus 2t cubed. We'll derive this function to get our velocity. And so, to find the derivative of this function, we'll use the power rule. 24 multiplied by 1 will give us 24. 1 minus 1 will just give us 0. And that will just give us 1. And 3 multiplied by negative 2 will give us negative 6. 3 minus 1 will give us t squared. Okay, remember what the question asked us to find. The question asked us to find the magnitude of the acceleration when our velocity is equal to 0. So what this means is that we'll have to substitute a 0 because the question asks us to find the magnitude of the acceleration when our velocity is equal to 0. Okay, so let's substitute 0 over here. We now have 0 is equal to 24 minus 6t squared. And so if we transpose negative 6t squared, we'll have positive 6t squared is equal to 24. And if we divide both sides by positive 6, we'll have t squared. 24 divided by 6 is equal to 4. T squared, if we square root both sides, if we square root t squared and we square root positive 4, we'll have t is equal to positive 2, or t is equal to 2 seconds, or t is equal to negative 2 seconds. But we know that our time cannot be negative, so this must be the correct answer. And so now we've found that when our velocity is equal to 0, the time is equal to 2 seconds. Or when our velocity is equal to 0, it is at t is equal to 2. Alright. So continuing with our question, the question, remember, we're supposed to find the magnitude of our acceleration when our velocity is equal to 0. So to solve for acceleration, we know by now that acceleration is given by the derivative of the velocity with respect to time. So I'll just write that over. Okay, let me just erase this. We know that acceleration is given by the derivative of velocity with respect to time, or simply dv over dt. But hey, if you look closely over here, we found our velocity function. So what this means is that we'll have to find the derivative of this function and we'll have our acceleration. And so let us find the derivative of velocity with respect to time in order to get our acceleration. dv over dt is equal to 24 minus 6t squared d over dt. And so we know that dv over dt will give us our acceleration with respect to time. And so we'll solve this using the power rule. The derivative of a constant is equal to 0. 2 multiplied by negative 6 gives us negative 12. And 2 minus 1 will give us 1, so I can just drop the t. And so this now gives us the acceleration as a function. To find our acceleration, we'll have to substitute t is equal to 2. So wherever I see t, I'll substitute 2. And so negative 12 multiplied by 2 gives us negative 24 meters per second per second. And so now this is our acceleration when our velocity is equal to 0. Remember, the question asked us to calculate the magnitude of the acceleration when our velocity is equal to 0 meters per second. And this is the acceleration when our velocity is equal to 0. To find the magnitude of acceleration, this will simply become positive 24 meters per second per second. We have now reached the end of the video. Thank you for watching. Make sure to like and subscribe. See you in the next video.